In this video, we're going to go over how to add or subtract rational expressions that have common denominators. To do this and understand why it works, let's go over an oldie but a goodie. So let's say I have something like, I don't know, 1/7 plus 3/7. So they have common denominators. We have the same units, so to speak, in the bottom. So if I have 1/7 and 3/7, I can add those together. We'll get sevenths, and you'll be doing 1 plus 3 because it's like 1 of those sevenths and 3 of those sevenths gives me a total of 4/7. So that's old school addition of fractions. Well, we're going to do the same thing now in these problems. The only difference between the sevenths and something where we have variables in the denominator, well, is that the denominator is variables. It's still the same exact idea. Our units now in our denominator are x's, if you will. And if you don't know what I'm talking about with units, look back at my pre-algebra or even earlier middle school videos on how to add and subtract fractions. So we have the common denominator, so we keep the denominator, just like with the sevenths. So it's going to be over x, and then we add 1 and 3. We add the numerators, which is 4 over x. That's it. Just like with sevenths. The only difference, the denominator has a variable in it. Now, like we did in previous videos with multiplying and dividing rational expressions and simplifying them, we have to state restrictions. So what value would make the denominator 0? That would be 0. So x cannot equal 0. That's it. Not so bad. So let's do some more addition. So we'll take a look at b. So in b, we have negative 6x plus 1 plus x minus 5. Each of those have a common denominator of x plus 4. So I know that my final answer is going to have a common denominator of x plus 4, and we can now just combine the numerators. Negative 6x plus 1 plus x minus 5. And all I do is now combine those like terms in the numerator. So that's going to be equal to, well, negative 6x and x is negative 5x. 1 minus 5 is negative 4. And that's all over x plus 4. Not bad. So what you should always do when you get down to that final answer part right here where you've combined the numerators, check to see if there's anything you can factor, because sometimes the numerator and denominator will be able to simplify down. Just like sometimes when you added fractions, like if you add, let's say, 2/3 and 4/3, you end up with 6/3, which can simplify down to 2. So here, there's no factors to simplify down to, so no worries, but we do need to state our restrictions. X cannot equal whatever makes the denominator 0, and that would be negative 4. Awesome, not bad. Okay, we're gonna go over one now where we have a beefy amount of information in the denominator, and we're subtracting. How do we deal with that? Well, again, just look at this as the same exact denominator, so we keep them. So that's gonna be all over x plus 1 times x plus 5, since we have a common denominator, and now we're going to combine the numerators. So that's going to be x squared minus 3x. Now be careful here. This is not minus x plus 2, right? You don't just write minus x and then a plus 2 there. You're subtracting everything that is in this numerator. So we are subtracting all of x plus 2. Beautiful. So now we'll simplify it down a bit. So the numerator becomes x squared minus 3x. Distribute that negative because it's subtracting all of it. Minus x minus 2, right? Did that distribution. All over the common denominator. So I'm just copying that part. That's not bad. And now what's left is just combine all of the like terms. So we're left with x squared minus 4x minus 3x minus x minus 2 all over x plus 1 times x plus 5. So now, the numerator, there's no nice numbers that multiply to 2 that will combine to 4. So I can't factor that out and expect any of those numbers to divide out with it. So we're done in terms of simplifying, but our restrictions we need. X cannot equal to anything that makes a denominator 0, so x can't be negative 1, and x can't be negative 5. That's it. When you got common denominators, you keep those denominators, you add the numerators or subtract them, as we saw in these problems. Sweet stuff. See you later.